By the end of today's lesson, you'll be able to work with native Ruby types like numbers, strings, Booleans, arrays, and hashes. Everything in Ruby is an object. This means that all types can provide useful information via the same dot notation that's used in most common object-oriented languages. In Ruby, these are called attributes. In this example, a string's length attribute is being accessed using dot notation. Ruby objects can also contain methods or functions that are attached to objects. However, the language makes no real distinction between attributes and methods. Instead, you can think of methods as messages that get passed to objects that prompt a response. Unlike a lot of programming languages, Ruby allows punctuation in method names. By convention, Ruby Boolean methods end in a question mark. In this example, you can see that we're calling the empty method on the string lambda, and then calling the same method on an empty string. As expected, the responses are false and true, respectively. Next, we'll talk a little bit about strings. And first, we're going to talk about literals. So similar to other languages, a Ruby string literal, or a sequence of characters typed literally, is created using the quote character. In the REPL, the evaluation of each line is printed to the console, so typing a string literal will result in the string being printed. In Ruby, you can join strings or concatenate them using the plus sign operator. So in this example, we have a string hello, and then we're adding or using plus to concatenate the second string world. Now keep in mind, you can see that concatenation will combine your strings exactly as you provide them, in the same order without spaces or punctuation. So to write hello world as we normally would, we actually have to have the first string be hello, comma, space, and the second string be world, exclamation point. You can also manipulate strings using interpolation. String interpolation in Ruby allows you to reference a variable from a string and have its value inserted at runtime. For example, let's say you had a variable first name, and that variable changes. You don't know what it's going to be. You could create a string literal introducing the person whose name will be stored in first name, and you use the notation hash curly brace and then a closing curly brace inside of the string. Let's look at an example. So here we are setting the first name variable to Samantha, and then we are typing a string literal that says, hi, my name is. Now where we want Samantha to be printed, we end up using the hash and the open curly brace and close curly brace and putting that variable in between those. And then you can see in the console that hi, my name is Samantha is actually printed. Next, we need to talk about numbers. So Ruby supports a number of simple mathematical operations, all the things you'd expect. So we can add numbers, we can subtract numbers, we can multiply numbers, we can divide numbers. Now one thing you'll notice when we do an example with division, right? So first we'll look at 12 divided by 5. The return value is 2, which is not exactly what you might expect, but Ruby uses integer division by default. If you want to use floating point division, one of the numbers in the operation has to be a floating point number. So we can replace, in the example, the 5 with 5.0, and we can see the result is printed as 2.4. Now for advanced mathematical operations, Ruby actually contains a math module. And in that math module, there are some constants that are contained. So in this example, you'll see that we're accessing the pi constant and printing the value of pi. We also have some methods available, like square root or cosine. Now, one thing to take note of is the double colon notation and the fact that the constants are in all caps. This is the characteristic way to write constants or reference constants in Ruby. Ruby also supports exponentiation by using the double star operator. Now, it's common in programming that you may need to convert a number to a string. The most common way to convert from a number to a string is using the toS method, which stands for toString. So here in our example, we're taking 2 and multiplying it by pi, storing that in a variable called circle constant. Okay? Now, if we want the circle constant to be printed as a string, we simply call the toS method on that variable, and you can see the result. The toS method also works on bare numbers. It doesn't need to be called on a variable, obviously. Here we're writing 3.14 and then immediately calling toS on that, which prints 3.14 as a string. Now, what if we wanted to convert a string to a number? There is a very similar method called toI, or toInteger. And you can see in this example, we have 7 inside of a string, and we are, by calling toI on it, we'll print 7 as an integer in the console. If we want to go from a floating point number, or go from a string to a floating point number, we will use the toF method. Another type in Ruby is the Boolean. And once you start talking about Booleans, you often talk about comparison operators. In Ruby, the most common comparison operator you will see is the double equal sign, and it works in almost all relevant cases. So here we're testing if the length of the string lambda is equal to 6, and that does return as true, as you would expect. The return value in this case is the Boolean value, true. These values are incredibly useful for controlling the flow of our program, taking any action that's based on the result of a comparison. The next thing we need to talk about is controlling the flow with if. Okay? Using if in Ruby is quite simple. In this case, you see we're storing the string lambda to the variable password, and then we're testing if the length of password is less than 7. And if it is, we're going to return the string password is too short. Notice that an if block is closed with the end keyword. In Ruby, the parentheses are actually not required after the if statement. The following would be perfectly acceptable Ruby code. We can add a second behavior using the else keyword. Let's look at our code again. So we have a password variable that stores lambda school as a string. And now, in addition to checking if the password length is less than 7, we are adding an else keyword. And essentially that says otherwise. So in this case, if the password is greater than or equal to 7, we are going to return a string that says password is long enough. And now the end keyword is moved to that end of the block. Another keyword that has a special meaning is else if. In this case, the second E is removed, so it looks a little weird, but it's spelled E-L-S-I-F, all one word. So this is for the time where you want to check a statement with if, and then instead of just else, you also have another condition you want to check. So in this case, we can say, is the password length less than 7? And then otherwise, we can check again. We can say else if the password length is less than 40, then we're going to say the password is perfect. And then the last else statement will happen if it's greater than or equal to 40, and will return a string that says password is too long. In Ruby, like most other programming languages, you can combine and invert Boolean values, right? So there's different ways to do that. We have the double ampersand, which means and. We have the double pipe, which means or. There's also the exclamation point, sometimes referred to as a bang, which means not. So going back to the code and looking at that, we've changed that first condition to check if the password length is greater than 7 and also less than 13. So the length then can be 8, 9, 10, 11, 12. And in that case, we'll return a string that's password is just right. In the next conditional statement, you're using the else if keyword, and then we're also using or. So we're checking if the length is 7 or less than or equal to 7 or greater than or equal to 13. And in that case, we're returning a string that says password is too short or too long. And in the last example, we're using the not or the exclamation point, and we're saying if the password length is not equal to 0 by typing exclamation point and then an equal sign. And in that case, you'll see that it returns true. The next type we want to talk about in Ruby is the array. Now, array is a data type which is a general container for a list of arbitrary elements that are in a particular order. Okay? The simplest way to create an array in Ruby is just using an array literal. So in this case, we have a variable called myArray, and we just literally type the array out. So in this case, an array is the bracket, so we type an open bracket, and then in this case, we have a series of strings that are separated by commas, and then a closing bracket. Now when we hit enter in our console, it will return that array that we just created. Now what if you have a string value and you want to turn that into an array? Well, there is a method available on string called split. And you can see in the code what we're doing here. We have a string apple space banana space carrot. And we want to split that string on the space character, right? So by calling that method, we have a new array returned where anytime there was a space, that separated the items that are pushed into the array. Now in this example, we used the space to split the string, but you could use any character or sequence of characters to split an array. So let's use a different example. Here in our code, we have apple, comma, banana, comma, carrot as a string. And for that case, we want to split on the comma. In the next example, we have comma space in between each word. In that case, we're going to split on comma and space. Like I said, any sequence of characters. So in this last example, we have a string that's apple, lambda, banana, lambda, carrot. And we can split on the string lambda. And you can see that that works. Now, what if no arguments are passed to the split method? The default is to split on any white space. So that's a space, a tab, or new line. And you can see in this example where we have these tabs and new line characters mixed in with our string, if we just call split, don't pass anything in, you can see what it does. Just like in many programming languages, you have to have a way to access values out of an array. In Ruby, we use bracket notation. One thing to note that arrays are zero offset, which means the first element in an array is located at index 0. Looking at our code, you can see here that we have an array that's being assigned to the variable list. Notice that if we try to access an index that's outside the range, so in this case, we tried to access the item with an index of 3, which doesn't exist in the list, a nil value is returned. This is actually different than many other programming languages, which would just return an error in this case. Ruby also supports negative indices for array access. Negative indices access the element in reverse, where -1 refers to the last element, and -n being the length of the array, refers to the first element. So if we do list -2, that would be the second item from the last item in reverse order. -1 is the last item. Now Ruby also has a special last method that will return the last item in an array. Now often in an array you might want to slice certain values out of the middle of the array or a certain portion of the array. First we'll talk about what a range is, because a range is crucial or is often used to slice an array. In Ruby, a range represents an interval, a set of values with a beginning and an end. You can construct a range using the start-end syntax. The first option is to have 2 dots in between. The second option is to have 3 dots in between. Let's look at the difference. So in the first example, we have 1.5, and we're calling the toA method or toArray method on that range. And you can see it returns an array with values from 1 to 5. In the second example, we use 3 dots in between to construct the range. And we pass in the A character and the E character as strings. Then we turn that into an array. In this case, notice that the E is left off. It only has A, B, C, and D. So the difference is when you use 3 dots, the end value is not included. With 2 dots, it is. To construct a range, you can also use the new method onRange. So looking at our example, we can call range.new and pass in 2 parameters, 1 and 5, and then call toA or toArray on that. You'll see it did the exact same thing as using 1.5. What if we want to do the second option, where we don't include the last item? In this case, we have to pass in a third parameter. So the third parameter, we pass in exclude end equals true, and then it will leave off the last value. The range data type is often used and is very useful to use in conjunction with the slice method. So in this case, we have an ages variable with 4 values, 22, 42, 33, and 27. What if we just want the values from the first index to the third index? In this case, we can just pass a range directly into the slice method. So we call ages.slice 1.3 being passed into slice, and we get an array with the items from index 1 to 3. In Ruby, you can also perform array slicing directly without even using the slice method by passing in a range to the bracket notation, as you can see in this example. That's actually the most common way you would see arrays being sliced in real-world Ruby code. Ranges can also be converted directly to an array. So if we want an array with all the integer values from 3 to 7, we simply call toA on the range 3.7. One method that you'll see used a lot is the include method. Both strings and arrays have that method available. The method does exactly what you would think it would. In this case, we have an array that is assigned to a variable called list, and we want to test if that list includes the string value lambda. In this case, it does, so it returns true. Now what if we want to test if the list includes the string value waste? We test it, and it returns false because the list does not include that. Often with arrays, you'll need to sort them. Ruby sorts an array of integers numerically, not alphabetically, as in some other programming languages. So in this case, you'll see we have a numbers variable with an array assigned to it, and if we call sort, it returns an array where the values are sorted from smallest to largest. Notice when we access the numbers variable again, the array looks exactly as it did originally. Ruby's sort method does not mutate the array in place. However, Ruby does have a sort bang method where it's sort with an exclamation point on the end, and that does mutate the array. In Ruby, most methods have a bang method version to use when you want to mutate the array. Now, often you'll have an array, you'll want to add a value or remove a value. To do that, we have a couple options. Pop removes the last element from an array and returns it, or it will return nil if the array is empty. Push will push the given object onto the end of the array and return the array itself. Now, one thing that you'll see in a lot of Ruby code that looks a little bit different is something called the shovel operator. It's a double less than symbol, and it's actually the most common notation for pushing onto arrays. Let's look at our example. So we have a list of strings. We have 2 strings, one of them being Utah, the second one being Michigan. Now we can add a third string, California, to list simply by typing list and then our shovel operator, again, which is a double less than symbol, and then the string California. The nice thing about this is you can easily chain your calls. So let's say we have 3 values we want to quickly add to our list. We can do that simply by just chaining the shovel operator one string after the other. Another data type in Ruby we need to talk about is a hash. Now, a hash is also known as an associative array. Hashes are similar to arrays, but instead of having integers as their indices, so instead of accessing the item with index 1 in an array, hashes allow generic labels. So I could have hash and then I could have a value stored with a key that was a string value. In this case, let's say email. Each element in a hash is actually a key value pair. In Ruby, empty hashes are represented by curly braces. In our example, we have a user variable, and we assign an empty hash simply by typing open curly brace, close curly brace, nothing in between. Now we can slowly add key value pairs to our hash by using that same bracket notation we used for arrays. Just like with arrays, if I try to access a key of a hash that doesn't exist, a nil value will be returned. Instead of adding items to a hash one at a time like we did in our last example, you can use something called a hash rocket. A hash rocket is an equal sign followed by a greater than symbol. Let's look at this code. So here we want to create an object or a hash. We're going to assign that to a variable called rocketman. And instead of doing the notation like we did last time, you can see we type the key, first name, then we use the hash rocket followed by the value. Now we can add as many key value pairs as we'd like, and in this case, those are separated by commas. Now a common Ruby convention is to put an extra space at both ends of the hash. It's not required, but it's often used to aid readability for the developer. Instead of using strings as hash keys, it's much more common to use symbols. Now symbols actually look a lot like strings, but they're prefixed with a colon. It's commonly said that symbols are strings without all the extra baggage. Let's look at a code example that will show what I'm talking about. So in this case, I have a string literal name and I call the split method on it. And I split by an empty string. So it will split on every character. We get an array with each of the characters in name. Now watch when I call that same split method on name as a symbol with the colon at the beginning. It returns an error. There's no method to do that. By using a symbol as the hash key, our keys don't make methods available that are unnecessary. Here's how you would use symbols as hash keys. So it looks just like our previous example, but instead of using our key as a string literal, now we're using the symbol. Using symbols for hash keys is so common that Ruby supports a custom syntax. So instead of having the colon at the beginning, which would mark the symbol, we actually put the colon at the end. And notice this also allows us to no longer use the hash rocket. This is actually the most common syntax to define a hash, and it looks very similar to other common programming languages. Be aware though that name with a colon after it has no meaning by itself. That syntax is only meaningful inside a literal hash definition. So now we're going to use the IRB to actually create and interact with a lot of the types we've just talked about. So let's use our own console. You need to open your console and follow along. So the first thing we need to do is type IRB into the console. And let's start by creating a full name variable that uses two other string variables by using interpolation. As you can see, the interpolation worked, and the first name value and last name value that we defined above was inserted into the string and stored in the full name variable. Now we're going to create an age and a net worth variable that hold numbers. Next, let's use a Boolean value to create an isCEO variable. Now, one thing we haven't used yet are those conditionals we talked about that you can use to control the flow of your program. So let's conditionally assign a value to a variable called responsibility. We'll go ahead and write if isCEO, and that will check if that condition is true. We are going to assign the extreme string to responsibility. Next, we'll create a companies array and fill it. Notice how we're using the split method and separating on the comma. Now let's go ahead and access and sort our array. Now we'll fill a children array using the shovel operator that we talked about. And let's use a hash to store all of our newly created variables in an entrepreneur object. Now, using everything we just went over, work in your own instance of IRB and create a hash that contains all of the following types. It needs to hold strings, numbers, booleans, arrays, and symbols.